Okay, looking at the first couple or the first 8 here, we're going to be using these choices, and we can use them more than once if we have to. But let's take a look at the first one. It says AD. So if we look, here's AD. And AD reminds me of something that's called a radius. So I'm just going to write out the actual word so that you can see it and not get confused. The second one starts at B and ends at E. It goes directly across the circle through the center, so it's a diameter. And then last but not least on this picture, this one says BE, but it has the arrows over top, so it's the entire line going through there. An entire line going through with arrows is called a secant. Sorry, I spelled that wrong. Secant. Okay. And let's take a look at this next one. It says 2 circles G. Okay, so they both have the same center. And it is going to be called concentric circles. 2 circles that share the same center, concentric circles. And then if we take a look at the next one, number 5, it says JK. JK starts and ends on the circle. That is a chord. Looking at these next ones, it says circle Q, which is the little circle here in the middle, and then circle R. And they happen to touch each other in one point, so we call them tangent circles. Number 7 asks us, what's this line, MN, called? It is a tangent line, so we're just going to actually just write tangent. And then last but not least, it's asking us, what is point U called? And that is a center. Okay, questions 9 through 14 deal back with the original first circle that we just talked about from the other side. And so the first one asks us for the arc measure ED. And so here's the arc right out here. Remember, it matches up with that central angle measure. So this arc measure is 30 degrees. And since it's a small arc, we call it a minor arc. The next one it's asking us for is the arc CD. Here's the arc on the outside. See, it matches up with that little box. If you remember, that box means 90 degrees. And it's still a minor arc because it's below 180 degrees. The next one we're talking about is C to E. So for all the way around here, and it takes in both the 90 and the 30. And so we need to add those together to get 120. And that's a minor arc. Our next one asks for CFD. So we're going to start at C. We're going to circle all the way to F. And then we're going to end up at D. So it's everything but the 90 degrees. So if we take 360 and minus 90, we're going to end up with 270 degrees. And that is a major arc. The next one is asking us for is CDF. So we start at C. We go to D. And we end at F. If you notice, it's a half of a circle. And so a half of a circle is 180 degrees. So we name that a semicircle. And then the last arc that it's asking us to find is FE. If we look inside here, FE doesn't correspond with any number yet, but we know that a half a circle is 180. We know that part of it's 30 and part of it's 90. So when we do that subtraction, it ends up being 60 degrees, which is a minor arc. All right, for some reason, 15 and 16 kind of got jumbled over on the side. So if we want to rewrite 15, it says BA, and 16, it says BE. Okay, and we're still looking at that first circle up at the top. So I'm going to highlight BA, and we want to find that distance. So if we look at our circle, it says 12 is the radius. BA is another radius, so that also has to be 12. And then number 16 asks from B to E, so all the way across the circle. And so if the radius is 12, the diameter must be 24 because I'm adding both the 12s together. Number 17 is a vocabulary question. And this vocabulary question was on a quiz before, so you probably can imagine it's probably on your test also. It says, what does every center of the circle lie on? And the answer is every diameter. Looking at number 18, it wants us to find M to H. So M to H is our blue line. If we just look next to it, there's a 10. And so M to H must be 10 also. Our next distance that they're trying for us to find is A to T. A to T is this outside part. It corresponds with that number down there, which is 24. Our next question, number 20, asks us for this angle measure, angle A. And that's always going to be a 90-degree angle because it's tangent to the circle. And then last but not least, we want to find M to T. So this requires us to use the Pythagorean theorem. So everyone go ahead and write out the Pythagorean theorem with me, because on your test tomorrow, there's going to be one exactly like this with different numbers. I'm taking the 10 squared and the 24 squared. I'm adding those together on my calculator. And when I take the square root of 676, I get my MT to be 26. So that's our answer for number 21. This one will for sure be on your test tomorrow with different numbers, so make sure you have down how to do it, how to set it up, and the process to solving it. Number 21 was also another quiz question that we've had. It says, how many common tangents do the two circles have? Well, common tangent means that it just strikes it in one point. So there's 2. And does everybody see the other one? The other one goes right down the middle. So there's a total of 3. Make sure you draw those in so you have an example, because again, that is a test question tomorrow. Looking at this diagram, we want to find out what the X angle is right here. We know that a whole circle is 360. And if we subtract off all the given numbers, remember the box means 90, and we throw that into our calculators, we end up with leftover of 150 degrees, which is X. Number 24 is a kind of a couple of step problem. We know that a whole circle is 360 degrees, and there's 12 numbers on a clock. So when we do that, we get 30 degrees for each one of the numbers. And then we count up how many numbers are there from 1 to 5. Well, 1, 2, 3, 4, 5. So we take our 30 and we times it by the number 5. We end up with 150 degrees is our angle measure. This next question, we got to find X, Y, and Z. So if we just look at X first, it's just this blue piece. And if you notice this 50 that's kind of hidden in there, so that's what X is. X is going to be 50. So if I write that over the side, X is 50. We also have to find Y and Z. Okay, I'm going to skip to Z real quick because Z is here, and all I have to do is take 50 plus 50, and that's going to give me 100 degrees. And then the way I find Y is out here on this side. I notice that it's part of a whole half circle. So if I take 180 and minus the 90, I end up with Y being I want to take 180 minus 50. Sorry about that. 180 minus 50, 50 degrees. So I end up with our arc measure of 130. 180 minus 50. Sorry about that. To find the value of x here, we just know that this piece is congruent to this piece, which makes this number congruent to that number, which makes our answer 100. Looking at 29, we just want to find x and y for both of these. Looking at the picture, if this whole thing is 10, what is half of 10? X is going to be 5. And then to find y, we know if this piece is 115, so is this piece. And a whole circle is 360. So I need to subtract off both 115s. And I end up with y being, sorry about that, 130.
All right, it's Mr. Robertson here, and we're going to go through these last couple questions together. So when we have a problem like this, number 1 on this back page here, it says find the value of x. We're looking for an arc length, okay? So we want to find the distance from here to here. And what we're going to do is we're going to look at this angle right here on the inside, and all we have to do is multiply this number by 2 to get our answer. So we just do 110 times 2, and our answer for that one is 220 degrees. For number 2, find the value of x. Okay, so x is right here. We're looking for this angle. Well, you notice there's a 75 in there. And we learned some properties about inscribed angles, and one of those are the ones on the same side are congruent. So this is also just going to be the same answer as 75. All right, looking at number 3, we have a triangle inside the circle, and that's called an inscribed triangle. And what we learned was the tangent, the point where the triangle touches here, that's always going to be 90 degrees, okay? So we can just circle 90 degrees. Another theorem or property we talked about is opposite angles being supplementary when we have a quadrilateral inside the circle. So these are the opposite angles. So supplementary means 180. So for this one, we just do 180 minus 46 on our calculators, and we get 134, which is C. All right, starting up at the top here, we have a 64, and we need to find out what the central angle is right here. So what we need to do first is to go from the inside to the outside. We times it by 2, so 64 times 2. That's going to give us 128. So we can put 128 outside here. That means from here to here is 128. And then when we work towards the center, those answers are going to be the same. So that's actually our central angle also. Number 6, find the value of x. So doing kind of like what we just did on the last problem, if we times 130 by 2, on your calculator, do 130 times 2, we should get 260. So from here to here is 260, and we want to know what the degrees is from here to here in blue. So all we have to do is 360, because that's the total of a circle, minus 260, and we find our answer to be 100 degrees. 100. All right, number 7, it says find the measure of angle ABE. I'm going to put an X. ABE is right here. And we learned a little formula for this one. When we have two lines that cross, two chords that cross on the inside, we're going to do the formula 0.5 parenthesis. We're going to have an addition symbol for these ones. And we're just going to do, it doesn't matter what order we put them in. We're going to put 180 plus 38. And then we just have to type this right into our calculator. Make sure you put the parentheses in. 0.5 parentheses 180 plus 38. And we get that degrees to be C109. All right, this one's a little trickier. We're going to use that same formula, the 0.5 parenthesis, but when it comes outside of the circle like this, kind of looks like a cone shooting outside, we got to put a minus sign. And this one actually gives us the x, the value that we're usually looking for. So to set this up, we would do 31 equals 0.5x, because we don't know what x is, minus 52. To solve this, we want to divide 0.5 both sides. It's going to cross out on the right. So in your calculator, if we do 31 divided by 0.5, that gives us 62. Equals, this x minus 52 drops down. At this point, we just have a one-step equation, so we're just going to add 52 to both sides. X is equal to 62 plus 52, which is 114 degrees. The last one on this page, well, it requires us to know how many degrees are in a total circle. So what we're going to do is start off by just doing 360 minus the 250 to figure out what the degrees is from this little section right here in red that I'm putting, okay? So 360 minus 250 is 110, so I'm going to put a 110. And now it's kind of like this problem we did up here, right above, but this time we are looking for x. So we're going to do x equals 0.5 parenthesis 250 minus 110. All right, you just plug it in your calculator exactly like that. Take a second and do that. Your answer for this one, when you plug it in, is 70 degrees, which is F. All right, next problem says find the value of x, and we are going to go ahead and multiply the terms that are on the same line. Okay, so, and we're going to set them equal to each other. So our first term will be 12 times x plus 1. And then if we look at the other chord that we have there, in red, we have 10 minus x and 10. So equals 10 parenthesis 10 minus x. So we're going to go ahead and solve this. So we are going to distribute 12 times x is 12x. 12 times 1 is 12 equals 10 times 10 is 100. 10 times negative x is a negative 10x. Now we have to get our x's by themselves. So I'm going to start by doing plus 10x both sides. Plus 10x here, plus 10x here. Alright, so that means that the 10x and the negative 10x will cross out. On the left side here, we're going to get 22x plus 12 equals 100. We have a two-step equation here now that we have to solve. So we're going to first subtract the 12 from both sides. And we'll get 22x equals, so that would be 88. We divide by 22. X equals 88 divided by 22 is 4. So we go back up and we circle C. All right, our next one, number 11, we have to remember that we have to do little piece times the entire amount of the segment, okay? So 5 plus 3, we can write an 8 above that. So we do little piece times the whole, which is 8, equals, little piece out here is 2 times the whole they give us as x, so 2 times x. So now we just solved this. 3 times 8 is 24. 2 times x is 2x. Divide by 2. X equals 12. Whoops, 12, which is E. All right, our next one, number 12, looks a little different. If you notice here in blue, do you see how this segment here stops and just stops right on the circle? That looks different from the one above. And the formula we have for this one is still we're going to do little piece times the whole on the top. So the whole would be 5 plus x. And we could scroll that out. So we have 5 parenthesis 5 plus x equals, now the important thing is this 10 right here, since there's only one number here, we're just going to square it. We're going to multiply these out. 5 times 5 is 25. 5 times x is 5x. 10 times 10 is 100. Get my x by itself right here, so I want to subtract 25. Both sides. That gives us 5x equals 75. We divide by 5. This one we get x to equal 75 divided by 5 is 15, which I believe is B right here. All right, number 13, we are going to skip number 13, okay? So you can just scribble it off on your paper. And let's go ahead and look at our equation of circles problem. So those are going to start up here on number 14. So it says write the equation of a circle in standard form. So let's just remember what our equation of the circle is. So our equation of the circle is always going to be x minus h squared plus y minus k squared equal to the radius squared. Remember the h and the k, those are going to be the center of the circle, okay? So it says right here that the center of the circle, which would be x and y, are going to get plugged in here, okay? So this, actually I should probably write this will be our h, this would be our k. So we're just going to plug these two numbers into our formula. So we would do x minus 5 squared plus y, we're going to change it to a positive 3 because that negative sign will cancel it out, equal, now looking back at the problem, it says the radius is 8, so we're going to do 8 squared. 8 times 8 is 64, so that is our equation right now there. So let's just try to find the match to it. Looks like it matches with B. All right, our next one down below, we're going to do pretty much the same thing, but we have a picture that goes with it. So it says write the equation of the circle in standard form, and here's our problem. So let's look at the circle, and our center is, well, we're going to go right 1, 2. So 2 comma down 1 would be a negative 1. And it looks like our radius is going to be, if we start at the center and go out 1, 2, 3, that's our radius. So now we're going to do the exact same thing we did above. I'm going to do x minus 2 squared plus y plus 1, because that's a negative and our formula has a negative, so they cancel each other out, makes it a positive, equals, and then we got to do 3 to the second power. 3 times 3 is 9. So then we just go and match it. It looks like our match is A, the first one right here. All right, number 16, I need you guys to make some changes to this problem, okay? So let's just cross this out. Just go ahead and scribble it out. And let's, over to the right, I'd like you to write center of our circle is going to be negative 1, 1. Our radius is going to be 5. So let's go ahead, and we don't even have to use the graph. We're just going to do the exact same thing and find which one of these equation matches what I've just told you. So we're going to plug this into the formula, x plus 1 squared plus y, this one will be minus 1 squared, equals, we want to do 5 times 5, which is 25. So looking through those, it looks like it would be C, this one right here. All right, let's look at the last page here. So it says, when considering a basic circle, which formula is incorrect? All right, so let's go through each one. Incorrect. So diameter is 2 times the radius. Well, that checks off because 2 times whatever radius is always the diameter. We can cross that out. The circumference equals pi times d. Well, yep, that's exactly what's in our notes as the circumference formula. Circumference equals 2 pi r. Well, since the radius is always 2 times the radius is always the diameter, That also checks off, okay? That's just another way to find circumference. So that means it has to be pi. Pi equals the diameter divided by circumference would not get us pi. Okay, calculate the arc length. We're going to use that formula that we learned about a couple of days ago, where we're going to take the central angle divided by 360, set it equal to the arc length that we're looking for here, which is x. And for the arc length, we're going to use 2 times pi times r. All right, so let's go ahead and plug these numbers into that formula. Our central angle is 110, so we do 110 divided by 360 equals x over parenthesis 2 times pi, or 3.14, times our radius for this is 7. So we're going to cross multiply then. So on your calculators, you're going to do 110 times 2 times pi times 7. You can pause the video right now if you want to practice on your own. But when you do that, you are going to get 4,835.6 equals 360 times x is just 360x. We're then going to divide by 360. 360 divided by 4,835.6 gives us 13.43. All right, we circle it. All right, the next question says, well, what did we do right here to find this, okay? So we just have to look through and find the one we did. Well, we did 2 pi 7, all right? So 2 times 7 is 14. So the only one that makes sense here is pi 14. It couldn't be this one because it's only 7 pi. It didn't have the 2, and we didn't use 49 at all. All right, the next problem says find the shaded area. I just took this picture right here and I pulled it from up here where it is on your worksheet, so it's fine that it's not there. I'm going to put it right here off to the left. So we only have to find the area of the shaded part of the circle. So let's find the whole circle, the area of the whole circle first, I guess. So if this is 4 here, we know that this is 4 going this way, and this is 4. I could write a 4 here. Let me erase this here, and I could write a 4 also here. So the radius of the big circle is 4, because halfway across would be 4. So to find the area, we're going to use pi r squared. So the area of the big circle would be pi 4 squared. Type that into your calculator. We can do a little rounding too. Pi 4 squared, or 3.14 times 4 squared. And you should have got 50.3. So that's what the area of the whole big circle is. Now we have to subtract out the two, like kind of the holes that were punched out of this, okay? So we need to, the radius for the little circle would be half of 4, okay? So we are going to, sorry, here, I'll put a little 2 here, and that one right there would be 2 also. So the area for the little circle, the small circles, this would be like the big circle, would be pi 2 squared. So pi 2 squared, we'll type that in our calculator. I think we get 12.6. Now that's only one of the little circles though. There's 2 white circles taken out, so we want to times that by 2. And we times it by 2, we get just, I'm going to round this to 25.1, okay? So our last step is we have to subtract out the 2 little circles. So we do 50.3 minus 25.1. And we find the area of just that shaded area of that circle, the big circle, to be 25.2 centimeters squared. All right, looking up at the top here, we only have 2 questions left. Okay, so number 5 went with, let me try to pull it up here. It went with, there we go. Went with what we just did here. It says, how do you know that that was the shaded area that we found? It's just asking us to explain what we did. So if you look here, the first one says 4 pi squared minus 2 pi squared minus 2 pi squared. And that's what we did here. We took the pi 4 squared, which was the whole, and then we subtracted out 2 of the little circles, which were each pi 2 squared. So the last problem, move this out of the way, deals with this picture right up here, okay? So I'm going to put an arrow down here. It says, given the circle and the sector areas to find the measure of the central angle. So sector area, our formula for that was the central angle divided by 360 equals the sector area, and then pi r squared was the formula we had below. So they're going to give us a lot of these answers, which is good. It's going to make it a little easier for us. So we don't know the central angle. That's where our x is. If you look up here, there is, I'll put it in red. We have an x right here. So we're going to do x over 360 equals, they give us the sector area right here. They tell it's 40. So 40 over, and they also give us the area of the entire circle, 200. So we don't even have to actually use the formula because they give us the answer. Now it's just a cross multiply problem. So I'm going to do 360 multiplied by 40. I get 14,400 equals x times 200 is 200x. Divide by 200. X is equal to 72 degrees.